Welcome to the NCERT discussion, and we are discussing the second chapter of the NCERT, and this is question number 2.14. So it says how much energy is required to ionize a hydrogen atom if the electron occupies the fifth orbit, and compare this with the case when it is there in the first orbit. Okay. So as per the Bohr's theory, the energy for hydrogen-like atoms is given by minus 2.18 into 10 to the power minus 18 into z square by n square joules. So this is the expression that we use for the energy of an electron. Okay. So for hydrogen, this z is going to be 1. Okay. So when the electron is in the first orbit, so we'll say it is minus 2.18 into 10 to the power minus 18 upon 1 square joules. Okay. So if the electron is in the fifth orbit, so this will be given by minus 2.18 into 10 to the power minus 18 divided by 5 square joules. So if you remove an electron, the energy will be 0. So this is given by minus 2.18 into 10 to the power minus 18 divided by infinity square joules. So this thing is going to be 0, and this thing is going to be minus 8.72 into 10 to the power minus 20 joules, and this thing is going to be minus 2.18 into 10 to the power minus 18 joules. Okay, so this is the energy of the electron in various orbits. So if you are removing from the fifth orbit, then the energy required will be equal to the final energy E infinity minus the energy in the fifth orbit. So this is equal to 0 minus 8.72 into 10 to the power minus 20. So this is going to be 8.72 into 10 to the power minus 20 joules. Okay. So this is the energy if you remove an electron from fifth orbit to infinity. Now what happens if you remove an electron from the first orbit? So this would be 2.18 into 10 to the power minus 18 joules. So if we compare both these expressions, then definitely this is 10 to the power minus 18 and this is 10 to the power minus 20. So since in this case the electron is closer to the nucleus, so it is difficult to extract as compared to this orbit when it is in the fifth orbit and it is far away from the nucleus. Okay, so this is how you calculate the energy required to ionize electrons from different orbits. Okay, thanks for watching. I hope this thing helps you to understand the question.